In the previous section of this unit, we were talking about the fact that sodium prefers to have a positive charge and chlorine prefers to have a negative charge. We can actually talk about those preferred charges and the interaction between sodium and chlorine using the Lewis structures that we discussed in the previous unit. So, as an example, we can draw the Lewis structure of electrically neutral sodium. So this is sodium that is electrically neutral, and if you remember, sodium prefers not to be this way. But let's just pretend that we have a sodium atom that is neutral. We can also draw the Lewis structure for electrically neutral chlorine. Again, chlorine doesn't prefer to be this way, but we can say that we have a chlorine atom like this as well. And you can see that chlorine is missing one electron that would complete the outermost shell. And sodium basically has one too many. So what you can envision happening, actually, if you had electrically neutral sodium and electrically neutral chlorine, is that the chlorine could steal the electron from the sodium atom. And so here's the chlorine with a stolen electron that came from the sodium. Because it has one extra electron, the charge of the chlorine atom is now -1. Because the sodium atom lost its electron, the charge of the sodium is +1. And because these two atoms have opposite electrical charges, they're now attracted to each other and they stick to each other. And that's how you get table salt or sodium chloride. So what I want you to realize is that these are two ions that are attached to each other. This is a cation, and the atom on the right is an anion. And the attachment, the actual attachment that is taking place, in chemistry, it's formally called an ionic bond. And the reason it's called an ionic bond is because there are two ions, and a bond is just a way of saying that there's an attachment between two things. So the attachment between two ions is called an ionic bond. And ionic bonds, again, just formally speaking, occur when atoms stick to each other because they have opposite electrical charges. What's a bond? Informally speaking, I want you to think of a bond as a way of getting atoms or groups of atoms to stick to each other. An ionic bond, the type of attachment here, is only one type of bond. There are actually a number of others, and we're going to discuss a couple of the others. We won't discuss all of them in this unit. And because sodium chloride, or table salt, is made of two ions that are stuck to each other, sometimes sodium chloride and similar molecules are called ionic compounds. So they're called compounds because they meet the definition of a compound. There are two or more different types of atoms attached to each other in a fixed way, and they're ionic compounds because these atoms actually exist as ions. So now, at this point, I want to just briefly describe the preferred charge of a number of different atoms that prefer to have a positive electrical charge. So the way that I'm calling them here is I'm saying this is a list of some common cations. And if you remember, cation is just the formal chemistry term for an atom or group of atoms with a positive charge. So lithium prefers to have a charge of +1, and the way that you would write a lithium atom that had a positive electrical charge is you would write the symbol for lithium and a superscript to the right with a plus sign, which means +1. If there's no number written in the superscript, it just means the number 1 is implied. So sodium prefers to have a charge of +1, potassium prefers to have a charge of +1. There are atoms that have positive charge but not a charge of +1. An example of that is magnesium here. Magnesium prefers to have a charge of +2. And so you can write that as the symbol for magnesium and then a superscript to the right side with a 2 and the plus symbol. And you can write it the reverse way as well. You can write the plus symbol first and you can write the 2 to the right. Either way, it is perfectly fine. Calcium prefers to have a charge of +2. Aluminum prefers to have a charge of +3. So I don't expect you to memorize these. I just want you to be able to get used to reading them. If you see a superscript to the right side of a symbol, that is basically telling you the electrical charge of that particular atom. So these atoms here have a charge of +2. This atom here has a charge of +3. And the spoken name, you would still say this is a lithium ion, this is a sodium ion, etc., etc. With anions are the negatively charged atoms or groups of atoms. The spoken name is a little bit different, and I'll show you those here. So here's a list of some common anions. Fluorine prefers to have a charge of -1, so you would put a little superscript with a minus sign to the right of the symbol. And instead of calling it a fluorine ion, more formally speaking, you're supposed to call it a fluoride ion. In general, I don't think it's a big deal if you call it a fluorine ion. I just want you to know that formally speaking, you drop the INE and you add IDE. So this is a chloride ion. Chlorine prefers to have a charge of -1. Bromine prefers to have a charge of -1. Iodine as well. And just to show you that negatively charged atoms and groups of atoms can have different negative charges as well, here's oxygen prefers to have a charge of -2. And in this case, that ion is called an oxide ion. Again, I don't expect you to memorize the preferred charges, but you should be able to figure them out by working through the rules that we've discussed in this unit and in the previous unit. So another thing that I want to point out is what happens when you mix ions together to make ionic compounds. And the rules to remember here are, the most important rule to remember is this. The ions will pretty much always, as far as we're concerned, I put almost here as a little bit of a hedge, but as far as we're concerned, ions will always combine, they'll always attach to each other to neutralize each other, to make a net electrical charge of 0. And in general, it's customary to write the cation on the left side of the molecular formula. So as an example, let's talk about sodium. Sodium prefers to have a charge of +1. Chlorine prefers to have a charge of -1. And the question I would ask is, how many chlorine atoms, or how many chloride ions, do you need to neutralize a single sodium ion? And I'll pause, or you can pause if you'd like and answer this question. And it turns out you need one of these to neutralize one of these, because sodium has a charge of +1, chlorine has a charge of -1. So if you mix one of each of these together, they will neutralize each other. Next question. Magnesium prefers to have a charge of +2. Chlorine, again, prefers to have a charge of -1. How many chlorine or chloride ions do you need to neutralize a single magnesium ion? And you can pause again, try to answer that question. And the answer is that you need 2 of these to neutralize a single magnesium ion. And because you need 2 of these, if you mix magnesium and chloride ions in the right amounts, you will see that 2 chlorides will attach for every single magnesium. And so by basically following this rule that the ions will always attach to each other in order to neutralize each other, you can figure out basically how different atoms attach to each other, how many are needed to attach to each other to make a certain type of molecule. To make table salt, to make sodium chloride, you need 1 sodium and 1 chlorine. To mix magnesium and chloride together, what you need is 2 chlorines attached to each other for every single magnesium ion. Here's another question. What if you had a calcium ion, and calcium prefers to have a charge of +2, and a sodium ion? Sodium prefers to have a charge of +1. How many sodium ions do you need to neutralize a single calcium ion? And you can pause and try to answer this question, and we'll discuss it in a second. The answer is that this is a trick question. You can't neutralize something that's positively charged with something else that's positively charged. And so this may seem unfair that I brought this up, but it illustrates actually an interesting point. And the point is that if you know what type of electrical charge different atoms prefer to have, not only can you tell whether they will attach to each other, but you can also tell whether they won't attach to each other. And what you can basically figure out from this is that sodium ions will not attach to calcium ions.